For a question like number 10, the best place for me to direct you is the last slide of the presentation on test of proportions. I realized after presenting tests on means that I hadn't addressed these rejection regions, so what I do is I lay out on that slide in the test of proportions slideshow, PowerPoint, that here is all the possible values it could take on. The only times that you're going to need to be considering are alpha equals 0.01, alpha equals 0.05, and alpha equals 0.10. On that slide, it literally tells you for each of those three alpha values, here's what the answers would be for a left-sided test, here's what they would be for a right-sided test, here's what they would be for a not equal to test. So when you're taking this test, I highly recommend that you have that slide in your notes and you're really just copying over from that. That said, I'm going to show how we arrived at those answers. So if I have a left-tailed test with alpha equals 0.01, graphically what's really happening is I want to have a rejection region on the left side of my graph where there's 0.01 region in here. What that means is I'm looking for a p-value of 0.0100 in the middle of the table. If I look for that in the middle of the table, I'm going to need to be on the negative side. On the negative side, 0.0100 is happening right around negative 2.32 or negative 2.33. Really, because it's 0.0099 at negative 2.33, that's the closest I can get to it. So what that tells me is my region of rejection starts at negative 2.33 and goes to the left. So the z-scores that will be rejected are the ones that are less than negative 2.33. That's why I'm going to put in the z is less than negative 2.33 to say that's where my rejections will occur whenever I get a z-score that's to the left of negative 2.33. This will always be the answer if it's alpha equals 0.1 left-sided. If this was a right-tailed test with alpha equals 0.01, it would be positive 2.33 that would go here, and there'd be no answer for the left side. If it said we want to do a two-tailed test with alpha equals 0.01, then really we'd have 0.005 in this edge, 0.005 in this edge, and that's going to give me a z-score of negative 2.575 and positive 2.575. There would be different answers if this was alpha equals 0.05 or if this was alpha equals 0.10. Again, all the possible answers are listed on that PowerPoint slide. In this case, since we don't have a right-sided region of rejection, we're just going to write the capital letters none because that's what the system tells us to do. State my conclusion if the observed test statistic is negative 2.12. Well, negative 2.12 would fall about here. If it would have fallen here in the shaded region, we would have rejected the null at the 1% level of confidence. Because it falls here in the unshaded region, our conclusion is we cannot reject or we fail to reject the null. Number 11 asks me to find the p-value for the z-test. It's a right-tailed test with observed z equals 1.07. For a right-tailed test, what we're going to need to do is look up the p-value associated with 1.07. Then because it's right-sided, we're going to do 1 minus that p-value. So when I go to my positive side and I look up 1.07, I get a p-value of 0.8577. 0.8577. If this had said left-sided, I would enter that in as my p-value. Because it says right-sided, I do 1 minus 0.8577. That gives me 0.1423, which is the p-value for this test. Other way it could be asked, a two-tailed test with an observed z. That's the hardest one to do. If it's a two-tailed test, basically a negative observed z, I'd look up the p-value and double it. A positive observed z, I'd look up the p-value, do 1 minus it, then I would double this answer before I reported a p-value. So for a right-tailed test like I have here, I do 1 minus. For a left-tailed test, I just use the actual p-value from the sheet. If it's a two-tailed test, I need to consider which side I'm on. If I'm on the left side with a negative z, just double my table value. If I'm on the right side with a positive z, 1 minus table value, then double it.